Dysfunctional vet. This is a DIY drill a well part 3. You're still researching your area for the water depth. From drilling logs that we've looked at, we have topsoil, and then from 10 to about 30 feet, most areas of our region over, say, a 10-mile diameter circle from where we're at, we're going to be running into clay and gravel through here. Almost all regions are reporting a water strata of 3 inches thick. Not a good pick unless it's the only water that you've got, because there just won't be that much in there. From basically about 30 feet down to 60 feet, it's a mix of different types of soils, shales, clays, sand, gravel, all kinds of junk. And then you come down into the water strata, which in this case, for our example, is sand and gravel. All right. I didn't see half of that. From 30 to 60, it's mixed, and then the sand gravel for 20 feet of water strata. Let's look over here at this. The weight of water. You have 1 cubic foot of water. That's 1,728 cubic inches. Fresh water weighs 64 pounds per cubic foot. Salt water weighs 65 pounds. When you start mixing in driller's clay or bentonite clay into water, when you're putting in the drilling gel, you're going to change the weight of this quite a bit. That's where you use a mud scale, and I'll show you a picture of one of those in a minute. What that does is it increases the viscosity so that it picks up stuff and it pumps it out. The most critical issue of having the proper mixture in here is to keep your bore from collapsing. This will be adding pressure to the bore, and it keeps it from collapsing. It acts as a, if you will, a wooden plug inside the well, which keeps everything from falling out. We all know that holes will collapse. If you have the right amount of bentonite clay in your drilling fluid, then you'll have the right amount of pressure to keep your bore open. Now the bore pressure, as you go down, becomes more and more and more. This is real important, so pay attention. The volume of your bore is the radius squared pi times the depth. You have to convert the bore into feet. So if your bore is 6 inches, 6 divided by 2 is 3. So 9 times pi times the depth will give you the pressure, correct? No. This 3 has to be converted into feet. So you divide 3 by 12, you come up with the number, you square that, multiply that by pi, and then by the feet that you're going down. And now you have the number of cubic inches that you're going down, and you can figure out that a 1 inch column of water down this bore depth is, sorry, I'm being distracted by my dogs. One of them's about to attack another. This will tell you what that pressure is downhole. How many pounds of physical pressure is being exerted on the bottom of that hole, which is important so that you have the proper pressure on the sides of the wall as well. You have a mud pump, and a mud pump is measured in head. Let me see if you're still on the screen here. A mud pump is measured in head. Head is the number of feet that the fluid being pumped through that pump will rise up. You can convert this into PSI using this formula. A lot of mud pumps, the red line is what I was using, and if I remember, it has 92 vertical feet of head, and we can convert that to pounds per square inch. So when the pressure in the bore, as we're drilling down, when the weight of the mud in that bore equals the head pressure, you lose circulation because everything balances. So you always want to make sure that your mud mixture will never equal the weight in the column. You'll always have more pressure in the pump than in that hole. The mud viscosity and head are very, very important to drilling. Your viscosity has to be thick enough to pick up the particles you're drilling. It has to be thick enough to hold the bore open, and it has to be thin enough or not dense enough that it ever comes close to matching head pressure. If that happens, you're going to lose that. I'll explain the rest of this in a white paper. Dysfunctional that out. Dysfunctional that. See if we can see their eyeballs. You can see the cows out there occasionally. Some of them have white faces. That's what you're seeing. I'm looking for my dog, if you're wondering what's happening with the light. Makar. Makar. I can hear my dog in the brush. I don't know where he's at. There he is. Good dog, Makar. Good dog. It's probably after a rabbit. I'm told squirrels don't crawl around at night. I don't want to blind my dog. You can hear my dogs off in the distance. They could be barking at anything. They could be barking at armadillos, possums, raccoons. The armadillos make a lot of noise when they go through the leaves, and they're basically nocturnal, although I have seen a few of them during the day, but not very often. And the only thing that makes more noise than a armadillo is a pack of pigs.